Okay, this is lab 3. We're going to be going over more print formatting, user input, as well as file input and output. So this lab wants you to make an invoice for 5 items where the quantities of each one of those items is input by the user in part 1. And then there's part 2 of this lab is also getting those quantities from a file instead of the user. So first, as defined in the lab, there's 5 items and each one of those items has a fixed price. So those are in the lab, but you need to include those prices somewhere in your code. So an easy way to do that is just like we're defining a normal variable. So we can say item 1 price and then set it equal to, let's say, so this would be $99.56 for item 1, and you would have 5 items, just like this. To specify that it's a constant, I can put the const keyword out front, and that just makes this variable a read-only variable. So if I try to do this and then try to compile it, we see I have an error assignment of read-only variable, and that's because of this const keyword. See, if I remove that, it compiles just fine. So next I'm going to get into rounding. Because these are prices, we don't really care about the third decimal place or anything after that. So let's say this price actually had 3 variables. We'll leave it at 2, and we'll see how it prints out. So this is a double. The type is a double, so I'm going to use %lf as my placeholder, and I'm just going to print out item1.price and run that. And we get a whole bunch of zeros at the end. So let's say I want to take those off. Now I already mentioned this in one of the earlier lab videos, but I'll mention it again. If you want to round a decimal, you put a decimal point right there, and then you specify after the decimal point how many decimals you want. So if I put 0.2 here, that's going to round this number to 2 decimal places. And see, there we go. We got rid of all those zeros. Next, because this is an invoice, it's going to involve a lot of lining up of numbers. So let's say I have a second item price here, and I'll make that shorter than the other one, and I'll print that as well. So it's going to be item 2 price, and we'll see how that looks. Now for an invoice, ideally you'd want the decimal points to line up with each other. It gives it the cleanest look. So in order to do that, I have to add some spaces in front of the 9 here. But so I could technically just do this, but what if these are variables? I can't hard code these 2 spaces here. So what I can do instead is, I'll move this down here. What I can do instead is specify in front of the decimal point how many characters the entire number should take up. So if I put a 7 here, oops, that will specify that should be 7 digits in the entire number. So what that means is, looking back at this number right here, the 9.56, it currently has 4 characters. So I have the 9, the decimal point, the 5, and the 6 as 4 characters. So by specifying 7 out here, it would put 3 spaces in front. And if I specify 7 here, it would only put 1 space out front. And that's what we see. So now the decimal points line up. Now let's say I want to left align some text or add some spaces after the text. So let's say we already have this. I'll already round it to 2 decimal places, and let's say I have some stuff here. And we'll comment out this first bit, so all clear. So we see how the sum stuff doesn't line up either. And you'll run into this with the names of the things, and you'll see that on the PDF. So some stuff doesn't really line up here. So if we want to make that line up, what we can do is actually put, go ahead and put those numbers out front again. So that's 7 spaces. But if we put a negative number, or a negative symbol in front of the 7, that will put the spaces after the number instead of before. So now the whole number still takes up 7 spaces or 7 characters, but now those extra spaces are padded to the very end. All right, last 2 things we're going to do are converting your console, your terminal inputs and outputs to file inputs and outputs. So let's say I want to just print these item 1 price. I would just want to print these to the console, and then I'll say item 1 price. I'll comment these out. So this is currently printing to the console. Let's round that too. What do we say? What should we do if we want to output this instead to a file? Well, first thing you do is you need to open up the file. So I'll call this out file equals f open. Here is the path of the file. I'll just do output.txt. And here's the mode that we're opening the file in. So I want to write to it. So I'm going to use a W. And this will also create the file if it doesn't exist. And then every time I open a file, I want to make sure I'm closing the file too. So I'll say close out file. And if we don't specify this at the end, especially when we're writing to the file, it could potentially not save the file. As well as if you have this open in a loop or something, or you're opening many files, some operating systems only let you have a certain amount of files open at the same time. So by specifying or by closing the files, it allows us to open more later on. So I've got my my output files opened and closed, but I'm still not writing anything to it. So to actually write anything to it, I can just modify this print statement to, instead of writing to the console, write to the file. To do that, I just put an F out front. So it's now fprintf, and I change the first argument to out file. And it's just that simple. So now instead of printing to the console, it's going to print to my output file. And we can see, compile that. I'll run it. This file just got created in my folder, and there's the output. So this is exactly what we had in the console earlier, but now it's in the file. So next is going to be file input. So let's say I have a text file, input.txt, and I'll just put some numbers in it. 5, 4, 6, sure. Now, normally, to get these numbers from the user, let's specify 3 variables, v1, v2, v3, and I will use scanf to get those from the user 3 times, and I would get a integer, just like this, and one more time. And this would be v1, v2, and v3 here, here, and here, just like that. So now if I'll comment this out, and then let me just print these values so we can see that it's working. So 1, 2, 3, and there's my values. So let's say I want to modify these to instead take the inputs from a file. What I can do is similar to the last one. I do fscanf. I open up my input file. That's the same as before, except I'm opening input.txt this time, and I'm opening it in read mode. And then same thing, just like before, I want to make sure I'm closing it after I'm done with it. I've changed these to fscanfs already, and then I put the in file right there. So one issue though is that we're going to have is each one of these fscanf calls is going to try to read these in order. So for example, my input.txt doesn't actually look like this. It's not one integer after another. Instead, it's one integer followed by a new line. So when I read them in, I have to make sure to put those new lines there. And we see that there's no new line at the end of this line, so I wouldn't include it. Okay, let's try that out. 4, 5, 6. Yep, just like that. So we see that I've converted my scanfs to fscanfs to read them from the input file. Okay, that's all you should need to know for this lab. So it's 2 parts. First, you're going to make the invoice application that prints it to the console. Next, you're going to modify it based on these modifications that I just showed right here to output to a file instead. So you're checking off 2 programs at the end of the lab, and you're going to be submitting your C code as well as the input.txt files and the output.txt files. All right, that's it.